So just like we did with the sine and cosine functions, we can torture ourselves by bringing in transformations, by changing the amplitude, by changing the period, translating the graph up and down, although we'll generally ignore that one in these examples here, and we can introduce a phase shift, so translating the graph left and right. Now I have amplitude in quotes because technically none of these four functions, tangent or cotangent, cosecant or secant, have an amplitude because it's supposed to be the maximum distance that you get from the sinusoidal axis. And all of these extend up forever and down forever. However, that number, in this case the 3 that's out front, does have an impact on the graph. So instead of at the over 4s at those 45-degree angles, the graph being at 1 or -1, the graph is going to be at 3 or -3. So it does still stretch the graph upwards, but it just isn't quite as noticeable. And it's not truly an amplitude, so that's why I have it in quotes there. Period, we're going to do it the same, figure it out the same way as we did with the sine and cosine graphs, except for tangent, the standard period is pi. So we can say it's pi over b. Well, in this case, b is 2, so that means our period is going to be pi over 2. We have no vertical translation, there's no k, so there's no number being added or subtracted, so we are going to be centered on the x-axis. And we do have a phase shift, and we don't have a phase shift on this one. My apologies. So for this one, we're going to have to label up that x-axis. We're going to do it the exact same way as what we had done before. So now we're going to label our x and y axis so that we can sketch our graph. And just as we did before, for the x-axis, we're going to travel over to the 4th tick mark and label that with the period. So in this case, that's pi over 2. So that means halfway there we're at pi over 4, and then halfway before that would be at pi over 8. So every tick mark is pi over 8, so that means the third one is going to be 3 pi over 8. And we'll fill in a few others to round out our x-axis in a little bit. Along the y-axis, since we have an amplitude of 3, we can count by 1, so we can go 1, 2, 3. And again, that amplitude is going to be the location of those points that are halfway in between the asymptotes and the zeros. And so if we go back to our parent graph, tangent starts its cycle at 0, which means it has to end its cycle at 0. Halfway through the cycle, it has an asymptote, so that's at -4, or pi over 4 in this case. And then halfway in between the zeros and the asymptotes, normally tangent is at either 1 or -1, but because of that 3 out in front as the coefficient in the A position, we're going to be at either 3 or -3. So that means we have these curves that look like this. And then again, I need to extend, so I can add on another period. So I can count over 4 tick marks, 1, 2, 3, 4 from the asymptote, and put in another one. I can count over 4 from the end of that previous cycle at pi over 2, and that's going to be end of the next cycle, so that's going to be at pi. And then again, halfway in between those zeros and the asymptote, we're going to be at either 3 or -3. And so now we've sketched 2 full periods. For the next example, cosecant, we're going to do the same thing as we did for the parent graph, where we're going to go ahead and graph this as a sine function and then sketch in the asymptotes and the parabola type shaped curves for the cosecant graph. So our amplitude of our sine wave that we're going to sketch is going to be 2. Our period, we're back to that standard period of 2 pi over b. Well, if we take 2 pi and divide it by pi over 2, what we really need to do is 2 pi times 2 over pi times the reciprocal. So our pi's cancel out, so our period is going to be 4. Nice user-friendly number for us, as we experienced before. There's no vertical translation. There's no number being added or subtracted at the end of it in that k position. And there's no phase shift. There's no number being added or subtracted inside of the function. So we can go ahead and sketch our sine wave. So that means we have to label up our x-axis. So I'm going to go to the fourth tick mark, label that with a 4. Means halfway is 2, so that means we're counting by 1s. And so now, since it's a cosecant graph, we're graphing sine, so we're going to start our cycle at 0. We're going to end our cycle at 0, and halfway in between we're going to be at 0. And then halfway in between the first and second zeros we're going to be at a maximum, so that's going to be at 2 in this case. Go ahead and label up our y-axis because of that amplitude of 2. So I'm at 2, and then in between the second and third zeros we are at -2. And so again, I'm going to dot that in because that's not really the graph that we want. We want the cosecant graph, which we'll add in just a second. I'll go ahead and add a second period. So I'll go out 4 tick marks, 1, 2, 3, 4. And so at 8 is going to be the end of the next cycle. So halfway in between we're going to be at 0. Halfway in between those zeros we're going to be at minimum and maximum locations. So that's the framework for our cosecant graph. We've graphed the sine wave. So now we can go ahead and add in our cosecant curve. So remember that all of the zeros of the sine wave, our cosecant graph is going to have an asymptote because the reciprocal of 0 is undefined. So I'm going to put those in everywhere. And then we're going to have these right side up and upside down parabola type shapes at each location coming into contact with the original sine curve that we used to help us with our sketch. So we just have to remember that it's the blue graph is the one for our cosecant graph, not the green one. The green one is just there to kind of help us out. So our last one is a secant function. And before we get started with that, please note the change in the phase shift. The red there is now pi over 2 instead of pi over 4. This will just make it a little bit easier for us to handle it on the graphing side of things. But being that it's a secant function, we're going to graph the cosine function and use that as the framework for graphing our secant function. Now the amplitude there is -2, again in quotes because we know that these functions don't really have an amplitude, but we have to account for it. The period is unchanged from the standard 2 pi since there's no b value. There's no vertical translation. There's no number being added or subtracted after the function. And then finally the phase shift on this one we have as -pi over 2. Again, make that correction on your handout. So we're now set to label up the axes so that we can get the graph sketched. So I'm going to go to the 4th tick mark and label that with 2 pi, the period, which means the 2nd tick mark halfway there is pi, which makes each individual tick mark pi over 2. So pi over 2, pi makes 2 pi over 2 makes pi, 3 pi over 2, and then we'll fill in a couple extras when we're finished. We also need to label up the y-axis. So since we have an amplitude of 2, probably counting by 1s is not unreasonable. So we can count up 1, 2, 3 going up, -1, -2, -3 going down. Let's make that actually look like a 3. There we go. And so now we're ready to sketch our graph. So again, we're going to graph the cosine graph and use that as the framework for our secant graph. So we have a couple things going on here. First of all, we have a phase shift of -pi over 2, so I'm going to have to go to the left 1 unit as a result to get to that -pi over 2. And then we've got an amplitude of -2. So normally cosine starts at the top at a maximum, but instead this one's going to start at the bottom because of that -2 amplitude, and that bottom is going to be at -2 as opposed to at -1. So then I can count over 4 tick marks to get to the end of that first cycle. Halfway in between those two minimums, curve is going to be at a maximum. Then halfway in between those minimum and maximum points, the curve is going to be at 0. So I'm going to dot that in because, again, this is not really the graph that we're interested in. I'm going to graph one more period going forward. So 1, 2, 3, 4 tick marks. And we should label what the endpoint of that is. So if we're at 2 pi, every tick mark is pi over 2. So 2 pi is like 4 pi over 2, 5 pi over 2, 6 pi over 2. So our finish here is at 7 pi over 2. And likewise, the start of the original cycle here, since we shifted backwards, is at negative pi over 2. So back to that second cycle, in between those two minimum points, we're at a maximum. In between our minimum and maximum points, we're at a 0. So I'll dot in that second period. And so now we're ready to sketch the actual secant graph. So we've got asymptotes at all of the zeros. Since the reciprocal of 0 is undefined. And then we've got these alternating upside down and right side up parabola type shapes in between those asymptotes that just make contact with the maximum and minimum points of the cosine graph. And so finish out with these last couple, and then the first one and last one are chopped off just because of how the original cosine graph is formed.